Hello everyone! Today we will be uncovering the horrors of this in JavaScript. But first, let's understand the purpose of this beast. You see, in many programming languages, this usually points to the current instance of the class, while in JavaScript, this points to the current context of execution. Because of that, it's kind of dynamic. The value it returns depends on the situation, and this is the main source of confusion.
Confusion of the highest order!
To make it simpler, you can think about it like that. Whenever the code is executed and this is encountered, the engine looks at the object that executes the current function and binds it to be the value of this in that context. As we will see, in JavaScript we can bind this to a certain value ourselves. But usually this is happening automatically under the hood using different rules depending on the situation. But if you know those rules, you should be able to safely navigate this maze. But enough talks, let's see some examples. First, let's define a simple function called showYourself. Its only purpose is to print the value of this in console. If we invoke it just like that, we get back the global window object. This is happening because we execute the function in global context, so this is basically equivalent to window.showYourself. Since window is calling this function, this keyword points to that global object. But it's important to mention that I only say it for explanation purposes. In this particular case, under the hood it's slightly different. Window doesn't explicitly invoke the function. Instead, the value of this is initially undefined, and later JavaScript engine automatically resolves undefined to window. Anyway, let's continue. Now let's define a constructor function, for example person. Let's give it two properties, name, which will be provided by us, and showOff function, which prints out the value of this. We can reuse already defined showYourself function. Now we can create a new person and use showOff method. As you can see, now instead of window, we get the person, because it is the object which is invoking this function. Okay, now let's use object literal instead of constructor function. Let's give it property value of this, which will store this, and showOff, but this time instead of assigning showYourself function to it, let's define a new function, which will call it inside of it. Now, if we print out value of this and call showOff method, we will see that both of them return window object. Why is that? Well, in case of value of this property, value is assigned during the creation of the object literal. So you can think of it as if the surrounding context is using some kind of createObject function. And since we are creating object literal in global context, we get back global window object. In case of showOff function, you could think that it would return x, since it is the object that invokes it. But if we look at the code, we can see that showOff is an empty method which simply calls showYourself. But where showYourself was defined? In global context. It is part of window object. As we discussed before, this is basically equivalent to window.showYourself. If we remove this middleman and instead of using showYourself function, we will just use console log this, we will get our x, because now this piece of code is called directly by this object literal. Okay, so looks like everything is working as expected. Now let's make a tiny change. Let's use arrow function instead of regular one. It shouldn't be a big deal, right? Well, now suddenly it returns window instead of object literal. Well, the reason this is happening is because arrow functions handle binding of this in a very different way. First of all, it's not dynamic. Instead, it's set in stone during function creation. In addition to that, instead of binding it to the calling object, arrow functions inherit this from the parent scope. So, our simple rule that object that is invoking the function is what we get as this doesn't apply here. Considering that object literals do not create their own scope, we inherit this from global context, and value of this in that scope is window, so that's what we get. Alright, now let's move on and see some other examples. Let's add an array to our object literal and iterate over it inside showOff method using map. Now we need to provide the callback which will be executed. Let's say that we want just to print out value of this. Well, window object again. The thing is that here we have yet another exception to the rule. In case of callbacks, the value of this depends on how the callback is called inside function which is using it. And in case of built-in JavaScript methods, most of them don't attach callback to any object, and so this defaults to window. So what can we do about it? Well, we can use arrow function as a callback, and in this case, this exception overrides that exception and we get back our x. This is happening because arrow function behavior takes precedence and this is inherited from the scope in which function was defined. As we saw before, object literal doesn't create its own scope, but functions do. And since we are inside showOff function, we inherit value of this from that function. And what is the value of this inside showOff function? Object literal, so that's what we get. Another option that we have is to use secret ingredient, a hidden variable which is useful for just those type of situations. You see, a lot of JavaScript functions that accept callbacks also have a second optional parameter called thisArg, which is used to set the value of this so it can be used when executing the callback. For example, here I can say that I want person object to be the value of this inside callback. Other more useful option would be to specify that I want my current context to be referenced as this inside of callback function. Okay, but what if instead of out-of-the-box function, we are calling our own? For example, show yourself that we've been using this entire time. How do I make it so when I call it, it returns this with the value I want it to return? Well, here we can use 3 different functions for manual binding of this: bind, call, and apply. Let's see some examples. So, if I call show yourself from the global context, I get window object. But if I want it to be something else, I can use .call method. It invokes the function, with this being equal to value that we provide. If the function has any parameters, we can also provide them. Let's add some to our show yourself function. Now, if we get back, we can provide the value just like that, one after another. Instead of call, we can also use apply. However, as you can see, now we get an error. This is happening because apply expects parameters in a form of array. And this is the only difference between those two methods. The third one, called bind, also sets this to a particular value, but in a slightly different way. Let's quickly remove those additional parameters first, as we don't need them anymore. Okay, now call and apply can be very useful if you need to invoke your function once. But if you need to use it multiple times, bind would be a better option due to the fact that instead of invoking the function right away, it returns the copy of it with applied binding. Now I can invoke this copy in any place and it will always return the same value of this. Let me show you an example. So let's imagine that we have some simple function which simply prints out the value of this and then invokes the provided callback. Now let's invoke it using call, binding the value of this to person, and providing show yourself as callback. As we can see, the value of this inside my func is indeed person. However, show yourself still returns window. This is happening due to the fact that call and apply bind the value of this only on their level. Any callbacks inside such functions will still have dynamic value of this. But we can easily fix it with bind. If we use it just like that, we will pass the copy of the callback which will have the value that we provided. Okay, what else? Strict mode. If you don't know what it is, check out my video about that. To put it simply, it applies the whole bunch of restrictions. In case of this, it works almost the same with just one difference. If you try to return this in global context, you will get undefined instead of window object. But if you run console.log this just like that, you still will get window object. It works this way because in normal mode, this always has to be an object. So if you call a function just like that, without any manual bindings, this is essentially undefined. JavaScript can't leave it like that and forces it to be an object, which is a window in global context. Strict mode doesn't force this behavior, so undefined stays undefined. Okay, now let's take a look at this in event handlers. Let's quickly create some button, query it in our code, and then add event listener which will print out the value of this. As you can see, it returns the DOM element that triggered the event. Pretty handy. As you remember, when we were discussing this inside callbacks, I mentioned that its value depends on internal implementation, and in most cases, it would return global object. Well, here we clearly have an exception, where internal implementation makes sure that the source of event is returned. However, please remember that if you use arrow function instead, its behavior will take precedence and you will get window object instead. In addition to that, you need to know that if instead of add event listener you are using event handler in HTML, like onClick attribute, the behavior can also be different. If you are using this inside attribute itself, it will reference the element you are interacting with. But if you are using this inside function which is being used inside the attribute, you will get the window object. You can think about it this way. JavaScript code inside the attribute is essentially wrapped in a handler function that binds the value of this to the element. So if I pass the function to onClick, it will be invoked inside automatically constructed handler, which has appropriate binding, but this binding is not propagated to function used inside of it. So if you are still with me, let's summarize. If you have function that uses keyword this, you will get different results depending on how you call that function. If you call it just like that, you will get window object. However, if you are in strict mode, it will return undefined. If the function is a method on some object, like in constructor function or object literal, it will return that object. However, if you are using arrow functions, the binding depends on the surrounding context. In case of callbacks, the value depends on the internal implementation, but most of built-in functions will return global object. However, a lot of them have optional this argument, allowing you to bind the specific value. In case of add event listener, its callback will be bound to the element you are adding listener to. But if you use arrow function, it will still depend on the surrounding context instead. If you use HTML attribute to assign event handler and use this directly inside the attribute, it will return the element. But if you use this inside a function, it will return the global object. You can have manual bindings with call, apply, and bind. However, the binding sticks only to the method you are calling and doesn't automatically propagate to callbacks invoked inside. Well, that was a lot. But hopefully now you understand how this works in JavaScript. If you enjoyed the video, please leave a like, a comment, and of course subscribe for more. Bye!